Press the bell icon on the YouTube app and never miss any update from Tech Primers.
Let's get straight into the agenda. We're going to see what are microfrontends, we're going to see what are monorepos, who uses monorepo in the industry. We will look at the different tools and the frameworks which can be leveraged for monorepos. As a case study, we will look at how Swiggy uses monorepo within their ecosystem. And finally, we will conclude with limitations and when to choose monorepos for your projects. If you look at the evolution of monolithic frontends, this is how it goes. We initially had a monolithic application where there was frontend, backend, and the database all embedded within the same code base, and you deployed the same as a whole. So this was called as the monolith, like all we know. Things evolved from monolith into frontend and backend, where we split the whole monolithic code base into two different parts. The first one was called as the frontend, and the one which interfaces the front end was called as the backend. So we split the whole team into front end team and the backend team. From there, we evolved into something called as microservices, where the microservices architectures were more geared towards the backend part. So if you look at it, the difference between the front end and backend and the microservices is just specific to the backend, which got segregated in terms of domains. For example, here we have product, reco, basket, payment, all these are separate domains which are segregated as a separate microservice. And we also have an aggregation layer which is interfacing with all these microservices and then converging them into a separate front end. So it's clearly visible that the backend evolved and people were able to create scalable architectures for backend. Now for front end, how do we scale our application with respect to specific domains or products? So that's where micro frontends come into picture. So what are microfrontends? Microfrontends are basically microservices for the front ends. However, you cannot directly say these are microservices for front end, but you can call them scalable front end architectures. So let's take this example from Martin Fowler website. So here you see three different microfrontends. All these microfrontends are separate features which are built by separate teams. They're all present in a source code repository, and all these have separate responsibilities with different build pipelines, and they're all deployed as a separate application. So the orange, green, and the purple boxes are separate deployables, and all these deployables are basically composed into one in production. So this could be, you might be merging them at runtime, or you could be deploying these as individual components, and you have a container application which is all consolidating all your micro frontend calls. So let's take a look at this with a classic website. Imagine this is the website which we want to look at. So this is similar to how you have swiggy.com or maybe Uber Eats or whichever food delivery app which you use. So you have different ways in which you can browse restaurants, and you have your profile, you have search options, you have prices, and you have some images of food which are showing up here. If I drill down and split this whole web application, you have browser restaurants as a separate micro frontend, surprise me as a separate micro frontend, and my profile could be a separate micro frontend. And in order to glue all these together, we need to have a container application. So the container application is nothing but the root or the feed me page where you have other links or links to the micro frontends embedded within this page. Now, if I translate this to a container based app, this is how it looks like. So you have a container application which is feed me, which is the website name, and you have multiple micro frontends. For example, the whole search bar, the content is basically called as a browse micro frontend because by default it is returning some results and it is showing up in the UI. And we also have links to other micro frontends like browse restaurants, surprise me, my profile. If you go to any huge website these days, for example amazon.com or flipkart.com or maybe Paytm, you can see micro frontends being clearly used because all these individual links are basically individual micro frontends which are all contained in a single app called the container application, and then you're all linked to these micro frontends to have a complete view of the website. So essentially it looks something like this. So we will have end-to-end teams which are implementing micro frontends. For example, the same team which does front end will implement the backend and also the integration with the database. So this way the teams are segregated in terms of products. For example, there's a team inspire, there's a team search, team product, and then team checkout. So this is one model which companies follow in terms of having a full stack kind of a team which does both front end, back end, and also the database integration in one go. Though there could be individual products or individual deployables within the whole team, but they all function as a single team to achieve scalable architectures when developing UI related applications. This results in another pattern called as BFF. BFF is nothing but backend for frontend. You have a corresponding backend for a particular feature in a UI. For example, this is how a backend for frontend pattern look like. So you have a frontend, you have a backend, and then that corresponds to a database. Or the backend could be connecting to different APIs. For example, here we call it downstream service, but these could be any APIs or maybe connecting to queues, etc. We also have cross collaboration between these backends to the corresponding integration points. It could be either database or maybe downstream services. So BFF is a pattern which is evolved over the micro frontends. So you have a frontend and then the corresponding backend for the particular frontend, and it's termed as backend for frontend. Most of us use these kind of pattern in production, but still these are just the development practices and patterns used in order to create scalable architectures in the UI world. Now that we know what are micro frontends, let's look at what are monorepos. This is the classic definition which is given in the Wikipedia. In a revision control system, a monorepo is a software development strategy where code for many projects are stored in the same repository. So as the name suggests, it's called monorepo because it's mono, which is one repository, and then you have code for multiple projects which are stored in the same repository. That's what a monorepo is essentially. However, individual products can have separate life cycles as opposed to one in a monolithic app. So in case of the monolithic app, we know that the whole project is deployed in one go, right? But in case of monorepos, it doesn't happen the same way. You can have individual products or individual projects within the whole repo have separate life cycles compared to what we had in the monolithic apps. So these could be individual pipelines or individual deployables depending on the type of individual product which you have within the same repository. In short, you have one repository but you have multiple deployables and different ways in which you can deploy the repo because you have multiple projects within the same repo, and based on the context your deployment lifecycle changes. Now, who uses this mono repository in the industry? Most of the famous names like Google, Facebook, Twitter, Uber, all of them uses monorepo in some form or shape. Monorepos became very popular when Google exposed saying that they are using a single repository for both Gmail and YouTube. In fact, the whole company uses a single repository for storing all their code. So most of these companies use organizational monorepo because organizational monorepos are at the organizational level where everybody uses the same repo for adding code. However, there are projects like Spring Boot, Airbnb, and Swiggy, which we are going to see in this video. These all uses project level monorepo. So project level monorepos are segregated as an individual product or specific area for which you have a monorepo where you have multiple sub projects which can be hosted in a single repository. For example, Spring Boot is a single repository which is a project, right? Under VMware you have Spring Boot, but VMware doesn't have a single monorepo or an organizational monorepo. Instead, Spring Boot as a project has a separate monorepo. Same with Airbnb. Airbnb has a monorepo for their UI code and also a monorepo for their backend code. So these are two different repositories which they have separately. In case of Swiggy, I will explain that in the coming slides. Now, what are the different tools and frameworks which can be leveraged for monorepos? So there are a lot of tools which you can leverage in the front-end industry these days. I have just mentioned some of the most popular ones and some of them which I had used. So I had used Narwhal, so I'm putting it in the front. There are other tools like Lerna, which is again popular. Microsoft had created something called as Rush.js. It is now called as Rush because they moved into TypeScript. There is also a popular one called Yarn Workspaces, and finally Google's Bazel. So these are the logos in case you want to look at any of these particular tools. I have used Narwhal for creating monorepos using Nest.js because Nest.js comes as a bundle with Narwhal. Now that we understood the landscape of monorepos, let's understand how Swiggy uses monorepos in their food delivering app. Before moving into Monorepos, this is how their front-facing desktop mobile applications were exposed in the company. They had something called DWeb, which is the desktop website of Swiggy. They also had something called MWeb, which is the mobile website of Swiggy. So these are two different websites, and they had two different repositories. So when you open the website from mobile, you get a different version, and you open the website from desktop, you get a different version, and they were all served from a different deployment and different code base. So these are two different code bases which Swiggy had. They were all converging into an API proxy which is based on Node.js, and it was called a service. Obviously they call it service proxy, and these service proxy acts as the interface between different middleware components which are hosted behind the systems. We don't have much clarity on what are these, but at a high level, Swiggy had three different repositories, one called dweb, the other one called mweb, and then they had something called service which acts as an API proxy. And the tech stack which they had used was React, Webpack, and Babel. So they were using React for their front-end applications, and they were using Webpack for packaging, and using Babel they were compiling the JavaScript code into final executables. Now as the code base grew, Swiggy recognized that there are some patterns in which they were reusing code between the mobile web application and the desktop web application, and there are reusable code which are copy pasted, and these code are copy pasted, and then if there is a bug fix, then they had to do the same fix both in dweb and also the mobile web. In addition to that, adding the dependencies for React, Webpack, and also Babel becomes complicated, because when you keep on upgrading to different versions, you have to keep on upgrading both the repositories, right? So they had to do two different deployments separately, review them separately, and then again test them separately. So there was too much of effort going on in just maintaining the repository and the way you upgrade your code base. And obviously one can argue that you can extract the code from these two and then put it in a common library, but then due to the amount of code and the setup which is required, so it was tedious for the team to create a separate request and then work upon it, because there are multiple teams which are working on these repositories. Now what happened after they moved into monorepos? So when they moved into monorepo, they clearly changed the whole structure of the repository. So there was only one repository for all these three components, where they had the dweb, the mweb, and also the service proxy. So I have put that as a repo here. They had multiple modular folders or packages which were called as, for example, config, which had the webpack configuration, which is reused by both the mobile web and also the dweb. So when you are pushing code into the dweb and also to the mobile web, all the reusable packages are all coming from the config. These are all webpack packages. So if you upgrade one particular webpack, it gets upgraded into both the deployments. So all these are in the same code base, but then they are all deployed as a separate artifact. So UI has the package to create common patterns and the design which was used across the mobile and the web. So Swiggy was able to create a unified design both for the mobile web and the desktop web using the same UI package. Similar things happened in terms of the payments and the reviews, where different tenants were able to retrieve the payments information and the reviews information from these packages. Helpers were basically the common reusable logic which they had pushed into a separate module. There is something called daily. This is where swiggydaily.com is pushed into. So there are two reusable components which are used in the mobile web. That's why there is a separate folder called daily. Obviously cache module has the caching components both for the mobile and the desktop. Finally, they had the restaurant slug generator, where multiple tenants were able to use that for creating the restaurant URL. This kind of a logic helped Swiggy to discourage people from touching the modules which are used by multiple teams. So if let's say they want to touch cache, now cache is being used by both the mobile web and the desktop web team. So without their consent, they cannot do a refactoring, or in terms of a huge change, they cannot just touch the caching module. Instead, they will be forced to think if they have to have a new package, or does it make sense to add the new feature into the existing package. This created modularity and helped the code base scale much better. And in order to build all these, they were using Lerna as a tool to use within this repo for building them separately for all the three different components. Here are some of the pros which Swiggy thinks which helps them scale their front ends. They were able to commit the same fix for both desktop and the mobile web in just one commit, which was a huge bottleneck for them earlier. Reusability created a lot of flexibility in terms of reusing components across both the UIs. Dependency updates in terms of webpacks were easily handled with Monorepo because they could just update in one go and create different artifacts from the same update. They also have heterogeneity in terms of UI versus the mobile web package, where they were able to distinguish some of the components which they didn't want to have common. So you still can have heterogeneity in your code base. Also, finally, the code reviews were much simpler compared to the earlier case where the same code has been reviewed in two different repositories. Coming to the cons, since there are too many packages, this leads to longer bootstrap times, which is startup times for the website. In order to reap the benefits of the scalability of microfrontends, it takes more time for people to look at it because it's not just a single update in terms of backend or in terms of any code, it's an update in terms of process and the way the team functions. So it's going to take more time in order to look at the ROI or reap the benefits of monorepos. And finally, the code navigation became slightly slower because the code base is huge and the developers are now opening individual packages to work around that. These are some of the pros and cons which Swiggy has mentioned in their blog. So I took the whole case study from their blog. If you're interested in reading the whole case study, you can take a look at it from the link in the description below. Now moving on to the limitations of Monorepo as a whole, the first one is the code base. Since the code base is going to be a single code base, there are going to be challenges in terms of size. If there are too many images stored in the same code base, you need to look at the type of version control system which can handle this humongous code base. Of course, Git can handle to a greater extent, but if let's say your code base is more than 10 gig or something, then you might face issues with Git. That's why Google uses their own version control system. The next one is operational complexity. There is going to be a lot of pull requests which are going to be in the repo because there is only one repo for multiple teams to be contributing in the same repo. So there are going to be operational issues in terms of who's going to merge when, and the merge conflicts are going to be coming in because there are more teams which are contributing into the same repository. The next one is the payload size during runtime. What if one particular feature has a different version of a particular dependency and the other feature has a different version of other dependency? Now this creates longer runtime because your page is going to download JavaScript files every now and then because you have different micro frontends serving and adding different libraries during the course of time. This adds to the payload size and your websites could be heavier in individual parts. And finally, the environment differences. When you're testing your application locally, you might test it in a different fashion. And with micro frontends, with monorepos, you cannot deploy the whole app like how you will run it in production locally. So it could be tedious to set up your whole micro frontends with monorepo in your local compared to how you will deploy in production. This may lead to production specific bugs where you were not able to test something locally, but you were able to test only in your production or your test environments. Now, what is the conclusion here? Should I go with monorepos or not? The first thing to note here is monorepos are not monolithic. Monorepos are a way to manage multiple projects in a single repository. Without doing microfrontends, it is difficult to reap the benefits of monorepo as a whole. And Monorepo is not a silver bullet. It's not going to solve all your problems which we have. We need to identify what is the current issue in our code base and why doesn't it scale, and we need to decide if we can go with monorepos or not. I'll just summarize what we just discussed. We saw what are microfrontends. Microfrontends are a way to create scalable front-end architectures. Using monorepos, you can create multiple microfrontend applications and store within the single repository and have different life cycles for deploying these individual microfrontends into your corresponding runtimes. We saw different companies using monorepo in the industry by leveraging organizational monorepo or project level monorepo. We also saw different tools and frameworks which we can leverage for monorepos. We also discussed the case study of how Swiggy uses Monorepo for their UI code. Finally, we ended up discussing the limitations of monorepos. I hope you are able to understand and distinguish what are monorepos and how you can leverage micro-frontends inside monorepos. As always, if you like the video, go ahead and like it. If you haven't subscribed to the channel, go ahead and subscribe to it. Meet you again in the next video. Thank you very much.